In this video, I'll be showing you the field design app within SiteMetrix Grade and GradeMetrix. I'll start off by creating a new job. This is just to show you that you don't need a localization, line work, or surface file to use field design. The only thing you need is corrections from a local base or BRS network. We'll give this job a name of field design. I'm not going to load localization or line work. I'll go next. I won't load a surface. And I'll keep it with the default units of record, and my georeference will just be the default UTM as well. I'll go next and finish. You can still use field design with a job that contains a localization, line work, and surface, but it's a nice feature not to need one loaded. There are 4 different functions within field design. I'll start with flat pad. Flat pad is a tool that you will use to create a single elevation plane in all directions of the machine that will project out forever. First thing you'll do is give the pad a name. Once you name and create the field design, you can always come back to it under the Recent tab. The only difference between SiteMetrix Grade and GradeMetrix is this Record At drop-down menu. SiteMetrix Grade will only use the horizontal position of the receiver with the included rod height. GradeMetrix will allow you to pick 3 different positions using the bucket or blade. These 3 positions are left, center, and right. This is used to gather the north, east, and elevation of the current position of the machine. For instance, if you had a hub in the ground that gave a finished grade elevation to a housing pad, and you put the right side of your blade down on the hub, you'd want to choose right. And now the elevation coming from the right side of your blade will be used. So now that my blade is on the ground where I want to get the elevation from, and the correct position is selected, I'll press record. And now finish. You'll see in the cross-section and profile view, I have a flat surface and I have a cut field to the pad I created. While using any type of field design, all the other functions within GradeMetrix and SiteMetrix work, like vertical offset and your different focus points, and other apps like Topo. In plan view, you won't see line work because I don't have any loaded in this project. But if I had a building pad that I wanted to stay within the boundaries of, I could collect that using Topo. To do this, go Menu, go into Topo, create a file that you want to store the points to, and tell it OK. If I was trying to represent showing a building, I would drive to one corner of the building and tell it to start a line. I would then drive to the next corner of the building and record that position. And the 3rd corner. And the 4th corner. And then tie it back into itself again. Now you can see the outline of the building that I created, and I'm still getting my cut fill from the pad. This line would only be used to show me the limits of the building pad, because it will still give me cut fill outside of it. So the operator would have to make sure he's within the boundaries of that line. If you find the pad elevation is off and you'd like to adjust it, you can go back in and edit the flat pad that you already created. To do this, go to Flat Pad, your Recents tab, pick the pad that you named. You can adjust the elevation 2 different ways. If you knew you only wanted to go down 2/10 from the previous pad elevation, you could just subtract it from the current elevation. Or if you didn't know how much you had to adjust the elevation, you can select your position again and re-record. And now you'll be getting cut fill from the new elevation that you selected. We'll now move on to sloped pad. Whenever you want to move from one field design to another, you have to make sure to clear the initial design first. To do that, go Clear Design. It'll automatically check mark any of the designs that you have loaded and just tell it to finish. Now we can go back into field design and create a sloped pad. Think of sloped pad as a dual plane laser. You can project a specific percent away from the machine and also left, right of the machine. We'll start off by giving the sloped pad a name. And go next. It is now asking for the first point of the baseline we're going to create. The baseline is used to project the mainfall in a certain direction. From here on out in this video, I'll call this point point A. Just like flat pad, we'll want to use the position to record the horizontal and vertical information. Once you select the intended position, tell it to record. And then next. Notice as I move my dozer, my bearing and distance are changing with it. This is giving me a call out from the first point, and then also the slope. This is the difference between the first point and the current position. Once I get to the second point of my baseline, I simply tell it to record, and that will lock the bearing, the distance, and the slope in. To help you visualize what we're creating, I'll show you in 3D view. Let's just say we have an existing pad here and here, and we just want to tie in and do straight grade in between the two of them. You created your point A on the first pad, you tracked to the second pad and created your second point. Now we have a baseline tying those two pads together. Next thing we'll do is tell it what we want to do left or right of the line we just created. We'll leave our bearing, distance, and slope the way they are so we can tie in between the 2 points, and we'll go next. Now, this menu is asking us, what do we want to do left or right of the main line? If I leave Create an Infinity Slope Pad checked on, it'll project left and right forever at whatever parameters I tell it. This is what that would look like in 3D view. You can see it projected from the line left and right forever. Cross slope is used if we wanted to project a certain percent left or right of the machine, making it more of a dual slope solution. This is what it'd look like at a 0% cross slope. You can see at point A, we're projecting the same elevation to the left and right of the line. Let's say I wanted to add in a plus 5% cross slope. This is what it would look like. You can see at a positive 5%, I'm going up on the right side. If I wanted to go down on the right side, it would be a minus 5%. I'll change this to a positive 5% so you can see it in the cross-section view. Now in the cross-section view, you can see the 5% that we created on the cross slope, and then the 0% that was created from the baseline. There's still a couple other ways we can use sloped pad. I'll use the original pad I created before. I'll go next and keep point A, and I'll keep point B. Now when I go back into my cross slope menu, I'll check off Create an Infinity Sloped Pad. Now we can choose what side of center we want to project a pad and a certain width. There's 3 options. We have left, center, and right. For this instance, I'll do a 25-foot wide lane. And for now, I'll keep it at 0%. You can see in the plan view which way it's going to project the lane. If I change it to left, it'll go to the left. If I change it to center, it'll split the difference in between the two. What that will look like in the 3D view is you'll see I have it set to left right now. It'll project out a lane 25 foot wide from the baseline. If I want to use center, it'll project out half the distance of that 25 foot, so it'll be 12.5 foot on the left and 12.5 feet on the right. And then if I select right, it'll throw the whole 25 foot wide section on the right side of the line. Now if I want to add in a 5% slope, you can see in this 3D view, it'll project a 5% up and away to the right side. Again, minus would be down and away, and positive would be up and away. This is what it'd look like on the right side. This is what it'd look like on the left side. And this is what it would look like in center. It will not give you a cut fill once you go outside the surface. So in this instance, if I go 12.5 feet on the outside of the line, it will not give me a cut fill. And I'll show you that here. You'll see in my cross-section view, my lane stops at 12.5 feet from the right of the line. So as I move my dozer over there, once my focus point goes outside of that line, I'll stop getting cut fill, keeping the operator within the margin of the surface that was created. Now, we're ready to move on to ramp. If you're already using a field design and you want to create a different one, you have to clear the initial one first. To do this, go to Clear Design. It'll check mark the field design you're currently using, so you just have to check Finish. Ramp is one of my favorite field design functions. It's similar to sloped pad, except for you can have multiple different cross-section nodes. We still use the point A to point B method to establish the baseline and build off of that. You'll notice in this instance we have 3 different planes. We have a flat bottom trench with sloped sides. We also give you the ability to do vertical structures, like this image representing a trench. We give you the ability to create unlimited amount of nodes to the left and right of the baseline, giving you the option to create something as complex as this road prism. When I select ramp, I'm given 2 different options to create the baseline. From coordinates is the same way we used in sloped pad. You create a baseline off of 2 different points that you record using the bucket or blades position. Follow guideline is used in conjunction with a line work file that you would load with a localization. We'll start off using the from coordinates method. First, we give the field design a name, and then tell it from coordinates, and next. Just like sloped pad, we're given the option to change the position on the blade or bucket to record this information from. When you have the blade or bucket on your known reference point, press record. And then next. Now I'll position myself on point B. You'll notice again the bearing, distance, and slope is changing to reflect my movement. I can once again change the position of my record location. So for each recorded location of the baseline, I could have my bucket or blade on 2 different positions, if needed. Once on your second known point, press record. And next. You'll notice in the upper right, we have a cross-section view. This yellow dashed line represents the baseline you just created. And as we start creating cross-section nodes, you'll see it visually in this cross-section view. Side to center is referencing in which direction you want to build off of this location. When we initially created our baseline, point A was the first point we shot, and point B is the second point that we shot. Now imagine yourself sitting at point A, looking at point B. In that scenario, left would be on the left side and right would be on the right side. Under side to center, we're also giving a third option, both. This is like a mirror function. So any lane width or cross slope you create, we'll do it on both sides at the same time. In this scenario, I'll be creating a road, so I'm going to use both. Lane width is how far left or right do you want to go off the baseline. For this instance, I'll tell it 12.5. Cross slope works the same as before. If you add a positive value, it'll go up and away from the baseline, and a negative value would go below. So if I wanted a crowned road, I would want to put a negative 2% in. I'll now tell it to add, and you'll notice in the cross-section view, it gives me a visual representation of what I'm building. Now let's say I wanted to add a curb at the end of this 12.5 foot width. Curbs are usually vertical structures, which just means we wouldn't want to offset any amount. So for my lane width, I'll tell it 0. And now I'll change my cross slope method to delta elevation, which is represented by this triangle. If I put a positive value in here, it'll go up from the last node, and a negative would go down. And here I'll put 0.5. That means I'm going vertically up a half a foot. And I'll tell it to add. You'll notice in the cross-section view, we now have a vertical node. Now I'll create a sidewalk. I'll have a 5 foot width for my sidewalk, and I'll change my cross slope method back to percent. Usually sidewalks flow back into the street. So in this particular instance, I'd want a positive percent, so the sidewalk would be going up and away. Tell this to add, and now you'll see that new node created in our cross-section view. To finish this road, I'll create a cut slope on one side and a fill slope on the other. So since I want something different on one side than the other, I cannot use both, and I'll have to use the left-right function. I'll start off on the left side. I'll give myself a 10-foot inslope. Steeper slopes are usually represented by a slope ratio and not a percent. So to change this, again, I just hit the percent icon and switch to run to rise, or rise to run, depending on your country's format. Here in North America, we generally use run to rise. Since on the left side, I want my slope to go up and away, this needs to be a positive value. So I'll put in 3 and 1, making it a 3-to-1 slope. I'll tell it to add, and now I'll do the right side. Again, I'll give it a 10-foot width. On the right side, I want to go down and away, and this would be a negative value. So I'll put in -3 to 1 and add. Now you see in the cross-section views, I have my 2 slopes independent of each other. When I go next, you'll see a plan view of each node represented as a line. And finally, I'll finish. Now in my main screen views, you'll see the same plan view. In the cross-section view, you'll see the road prism that we just created, with the crowned road, the curbs, and the inslopes. And now I'll show you one more way of using ramp and the from coordinates feature. But again, I need to clear my initial design first. In the field designs I've done so far, we've assumed point B is always going to be on grade. Sometimes that'll not be the case, like an underground scenario, which I'm trying to show here. You'll have an initial manhole set to grade, where you can record point A on the invert of the manhole. You'll always have an invert or a manhole that you can record point A at its known elevation. They would then dig it to the second point or second manhole before it's put to grade. So you couldn't use the typical point A to point B that we've been doing. Point A would be on grade and point B would be on the existing ground, as you can see here in this cross-section view. So what we can do is record point A on the invert of the pipe and then track to the second location and record that position for the bearing and length. We can then manually adjust the slope as it's called out in the plans like shown. To do this, I'll start a new ramp and call it trench. We'll still use from coordinates method and go next. I'll then record point A at the exposed invert and go next. I'll then track my machine to the second position where the manhole will be placed. and record that position. This will give me my bearing and distance to that position, but notice the large slope value because point A was the manhole that was already set in the ground and point B was on existing grade. If we look at the plans, they'll generally call out a certain percent this pipe is supposed to be set at, and we can enter that in here. Now, point B's horizontal location is correct, and the new entered slope value will fix the elevation issue we have from not being able to record point B at its true grade. I'll go next. I'll change side to center to both and give it half the width of my bucket or trench box. For here, I'll just tell it 5 feet. So we'll have an overall width of 10 feet. Since I want a flat bottom trench, I'll give it a 0% crossfall and tell it to add. If this trench was not going to be very deep, I could leave it like this and then the operator will only see the flat bottom trench. If this was going to be a deeper trench, I could either add benching or a slope to make sure the trench was safe. In this instance, I'll give it a 15-foot wide, 1.5 to 1 slope and add it. Now you can see in the cross-section view, I have a nice defined slope and the flat bottom 10-foot wide trench. I'll go next and finish. You'll see that same cross-section view in the main screens and our profile with the 2% grade we inputted on point B. There's one final way we can use ramp, and that is to use in conjunction with line work. I'll open a job that contains line work, and now instead of using the point A to point B method, I can select and use any of these lines for my baseline. It'll extract and use the line's elevation to establish that baseline. So you have to make sure the line is properly elevated with the correct elevation. Where I see this feature being beneficial is redesigns on a job. So if I look at my cross-section view, you'll notice a flat bottom ditch here off the edge of the shoulder. Let's just say I wanted to make this a V ditch instead. To do this, I go into field design and select ramp. I'll give it a name. Instead of from coordinates, I'm going to pick follow guideline and go next. I'll tap the line that I want to use as my baseline. In the lower left, it will display the layer that the line is associated to. And now I'll go next. I'll switch my side to center to the right side. I'll give a lane width of 10 feet. I'll change my cross slope to a slope ratio and give it the desired slope ratio you want. Notice I use a negative value because I want to go down and away from the slope. I'll tell it to add. And I'll do the same thing on the right side to finish my V ditch. Now I'll go next. Again, you'll see the plan view of what we created, and I'll tell it to finish. Now in my cross-section view, you can see the new V-ditch I just created, and you can still see the proposed surface line, making sure that we tie it in both areas. The great thing about this tool is if your line has a radius, it will also follow the radius, like shown here. The final field design feature we have is to create a surface based off of points you record with either the machine or the rover. To use this, I'll just give it a name and go next. I'll choose from the list of existing topos I have in this current job, pick the topo that I want to use to create the surface from, and tell it to open. Now in the plan view, you'll see the points that it's going to use and the surface outline that it's going to create. I'll tell it next and finish. You'll now notice we're getting a cut and fill based off these topo points that I gathered earlier. We still have the ability to use vertical offsets, shown here, and this will also still show you your proposed surface if you have one loaded in the same project. You will not get cut fill from the proposed surface because it's only going to use the field design we created. We have a separate video showing you how to use the Topo feature within SiteMetrix Grade and GradeMetrix. So look for that in video if needed. And this covers everything you need to know about field design.